Guys, welcome back. We're at 11.6. We're in the second to last section of new material we're doing, and this is we're gonna cover this Tuesday, and then 11.7 on Thursday, and then after that we are done with new stuff. We'll start reviewing for your final test, and I have one small project for you guys to work on, so we'll talk about that next week. So for this week, 11.6 is about amortization. Amortization is just a fancy word for a particular way that you're paying off a loan. This is different from, we did do some long-term payments of loans before, but we were using the simple interest at that time. And for that time, it was like, what do you call it? For that time, we were paying the interest off the entire amount, right? So for amortization, this is actually a little bit better for you as a borrower, and this is more typical for what you'd see for like a car loan or any kind of big loans. For mortgages. Mortgages is just a type of amortized loan. And what happens is you pay off the same amount every month or every period, but part of it goes towards your principal, how much you owe, and part of it goes towards your interest. And as you pay, you owe less and less, so that you're paying, even though you're paying the same amount of interest rate, you're paying overall a smaller percentage than if you were to just do the calculation right off the top. All right, let's look at this top summary. It says in this section, we again have two formulas that are essentially the same formula but solved for different variables. So these are these two guys here, that P1 and this M1. If I just rearrange this formula for M, I get this bottom guy. Okay, the first formula tells you how large a loan you could take if you know the monthly payment that you can make, the interest rate, and the length of time over which the loan will be paid. So you have you have your budget, you have set aside say $1,000 or whatever it is, however much money that you can afford for your home loan or whatever. And based on that information, plugging in the rate, then you can figure out how big a loan that you can afford to take. That's this first value. First formula. Okay, moving on. These types of loans are typical in house purchases and are called mortgages in that scenario. So if you ever wonder what the word mortgage is, because I used to wonder a long time ago, I was like, what is a mortgage? Mortgage is just a fancy word for the loan on a house. And then this is the formula for the present value of an annuity. Okay, this is kind of confusing, right? Because we used annuity before to mean something totally different. But the difference was that's for the future value, and we use annuity to mean that kind of money that we're depositing over and over and how much we're going to end up with, right, in the future. That's different from now. This is the present value. Don't ask me why they use the same word for both formulas. It's confusing to me too. But they use present value for an annuity. Present value is the difference. That's when it's telling you how much you can afford if you know the monthly payment here. And even though I say monthly, this M doesn't necessarily have to be monthly. It's whatever payment you're making at the period. So if N is something like quarterly, then this will be your quarterly payment instead. Alright. The second formula tells you what your monthly payment would be if you know the loan amount. So it's kind of like the other side of that same equation. If you know the loan amount, the interest rate, and the length of time over which the loan will be paid. So in both formulas, N is assumed to be 12 for monthly payments unless otherwise specified. So if you don't see an N, that means you're just going to set N equal to 12. Alright, so there's the amortization formula. Amortization because you're making monthly payments to get rid of the loan, yeah? That's what amortization means. Now in both of these formulas, M is the periodic payment, like we said. P is the loan amount, or we can also call it the principal. R, this is the rate. T is the time in years. And N is the number of payments in 1 year. So kind of similar to what I meant before, right? R is still the same thing, percentage of the rate. P is pretty much the same thing, the present value or principal. T is the same thing, time in years. And it's slightly different, but it still is the number of times something happens in 1 year, right? Remember how we use N for the number of compounds in a year? Now it's the number of payments in a year. And then M is a periodic payment. That one's new. Oh, actually, no, wait, this is not new, because we saw this with annuities before, right? M was the number of times paid in a year as well at that time. So yeah, actually, that's not bad. Okay. Let's try the questions. That's pretty much it. That's pretty much the introduction.